Hello and welcome back to Unit 11. This part of Unit 11 is being recorded slightly differently, and the reason is because I'm on paper. I want to be able to show you what my right hand is doing, and I can't do that when recording a computer screen. In this part of Unit 11, we're going to demonstrate right hand rules. First off, let's begin by just what is a right hand rule? A right hand rule is a way of determining the direction associated with a cross product. There are a variety of ways of doing it. The one that I'm going to teach you here is, I think, the one that is least likely to get confused, if you will. I will illustrate how to do this on the next slide, but just going through it here. For the right-hand rule, A cross B equals C. I want to determine the direction of C, for example. I point the fingers of my right hand in the direction of the first vector, which is in this case A. I then rotate my hand such that my palm points towards the second vector B. And then your thumb gives the direction of the third vector, which in this case is C. So let's look at an example. A cross B equals C. Here I've set up a coordinate system. You can see the x-axis is at an angle. What this is really trying to say is that the positive x-axis is out of the page. It's an attempt to draw a three-dimensional system in a two-dimensional piece of paper, two-dimensional world. Okay. The other thing to keep in mind is if while you're trying to use a right-hand rule that you feel like you need to be Gumby, like your hand doesn't rotate that way, then rotate the paper. So for example, on this one, I can point my fingers out of the page quite easily. Oh, out of the page is up, sorry. But I can't easily get rotated around to get my palm into B. So instead, what I'm going to do is I'm going to rotate the paper along. So now I can point out, point into B. So my thumb is pointing along B. I can then, you'll hear me say, flip my fingers down. So flip my fingers down, they now point along B. And I look and I see my thumb is pointing towards me, which is the positive z-axis. So C in this case is going to point along positive z or upwards towards the top of the page, which is a good point. When working with three-dimensional vectors, you need to be very specific about your directions. So C, I'm going to say, instead of it being up or something like that, we're going to say that the positive z-axis is towards the top of page. Okay. Positive y is to the right. And we've already got positive x is out of the page. That way it's very clear what direction these vectors are in. Next, we're going to keep the same A and B, but instead of doing A cross B, we're going to do B cross A. So again, I can't get my hand to easily point along B, so I'm going to rotate the page again. So I'm going to point my fingers along B. I'm then going to rotate my hand so that I can point my palm out of the page. And you see, I'm not there yet. Out of the page would be here, in which case my thumb points towards the bottom of the page. So D points along negative Z, which is what you'd expect, because remember, for cross products, A cross B equals the negative of B cross A. They're anti-commutative, right? So if we look back at the first one we did, A cross B, if I can get them both on the page at the same time here, A cross B gave us C pointing towards the top of the page. B cross A gives us D going towards the bottom of the page. Let's do a slightly different example here. Here I have A pointing towards the top of the page, B pointing to the right, and again I'm looking for C, which is the result of the cross product. This one I don't need to rotate the paper for. A points upward towards the top of the page, B points to the right, And now you can see my thumb points in. That's going to be along the negative x-axis. I'm just going to make a note that that is into the page. Now, as you can see, this gets a little cumbersome. So there's another notation that is often used for doing three-dimensional vectors, and that is known as the arrow notation. For the arrow notation, you have two possibilities. You have a dot and an X. The reason it's called arrow notation is because the dot represents the tip of the arrow, which means you're looking down the arrow, so the arrow is coming towards you, or in this case, it would be out of the page. On the other hand, if you see the X, that means you're looking at the fletching of the arrow, which means the arrow is going away for you, or in other words, it's into the page. Okay. So here I have my X and Y axes. Okay. Again, I'm going to rotate the paper to make my life easy. Point along A. My palm points towards B. I can also rotate my fingers to point B. And I see that my thumb now points out of the page. So the vector C, I can just make a little note here, is going to point out of the page, and it will look like that. Okay, another notation. Let's now consider the example of arc length equals theta cross r. R is going to be a vector that points from the axis of rotation to a point on your thing that's rotating. In this case, I'm going to be rotating a cylinder. So R is going to point to this point over here, like so. Okay. Theta always points along the axis. So I'm going to let theta point upward in this case, towards the top of the page. So what direction does S point? So I take theta, point my fingers in the direction of theta, cross R, and at this point I see that it points into the page. If, however, I look at this point over here, R in that case points opposite. So theta cross R. Over here it is pointing out of the page. I could look at a point directly in front, theta cross R, in which case S points this way, or I could look behind and I would get S point that way. And you can see I have a rotation going here. I go from this way out of the page, that way into the page and around. So this is defining the direction of the rotation for this object. Now, this is not typically how I do this. Okay. Instead, the way I learned it, typically what you're given is you're told this thing is rotating. Let's say that we're told it's rotating counterclockwise.
Yeah.
Okay. If it's rotating counterclockwise, then what I'm going to do is I'm going to use my hand to map out the rotation. So it's going in, coming out, and coming around. And then I see that my thumb points along the axis, giving me the direction of theta. I hope this helps with cross products, and I will catch up with you shortly for Unit 12.